All right, welcome back, everybody. Moving on to 6.2, the law of cosines. Okay, so we already did the law of sines. Next, we're on to the law of cosines. This will be just a single video lesson. Cosines is a little more straightforward. There's no ambiguous case we need to worry about. There's one or two tricks to it, but for the most part, cosines is maybe a little more straightforward than sines. Okay, so let's give you the law of cosines here quick. For any triangle, ABC, okay, and the big thing here is any triangle, okay, it doesn't need to be a right triangle, acute triangle, obtuse triangle, okay, these laws work for any triangle. Okay, so if we have our angles ABC and side lengths little a, little b, little c, we have these three equations. Now it looks like, holy smokes, three different things to memorize. Once we look at them, you'll notice that they're all kind of the same equation. Okay, we have a squared is equal to b squared plus c squared minus 2bca. And then again, these other two are really the same thing, just kind of switching the letters around. Notice that whatever is first is also last, little b and big B. Okay, and then it's just the other two letters, AC, AC in the middle. Same thing, C's are on the outside, and then AB, AB in the middle. Okay, so again, it is technically three equations, but they're all kind of the same one. If you can memorize one of them, you can memorize all of them. All right, so let's jump straight into using the law of cosines. I'm not going to worry about proving that for you here just because I might not be able to do it, and it would take 10 minutes, so we'll skip the proof for this one. Let's just show you how to use it. So just like with the law of sines, we're going to give you some parts of a triangle, and we want to solve that triangle. So let's draw that triangle we have out. Okay, so we're given B is 35 degrees, little a is 43, little c is 19, and we want to find big A, big C, and little b as well here. Okay, now since this is in the cosines section, it's obviously a law of cosines question, but one of the tricks for the actual test is going to be deciding, is it a law of cosines or law of sines problem? And what I'd recommend to do, I guess, is check the law of sines first. So let's set up our law of sines. So we could say sine of A, which we don't know, over little a 43 is equal to sine of B, which is 35, over little b, which we don't know, which is equal to sine of C, which we don't know, over little c 19. Okay, so as you can see here, law of sines would not work for this one. Okay, I don't have any one fraction that's filled in with two parts. So no matter what equation I'd set up here, I'd have two variables I couldn't solve. Okay, so I'd say kind of check the law of sines first. If law of sines doesn't work, we know it's a law of cosines problem. Okay, so let's go ahead and do that. I'm going to, just for a visual divider here to help me out. We need to figure out what equation to use. Basically what I need to do is pick the equation which has everything filled in except for a single variable. So for example, I couldn't use the first equation because I don't know both little b and big A. Okay, the one I'm going to use for this one is the second equation because I can solve for little b using little a, little c, which I know, and big B, which I also know. Okay, so let's set that up here. We have b squared is equal to a squared plus c squared minus 2ac cosine b. And toughest part for me is just going to be fitting this all on the one screen here. We'll do my best. All right, so I don't know b squared, but that's equal to a squared, which is 43 squared, plus c squared, which is the 19 squared, minus 2 times 43 times 19 times cosine sheet here of 35. Kind of wrecks the point of that, but oh well. Okay, and if I want the b by itself, I just need to get rid of the squared. So all I need to do that is take the square root of both sides of the equation. So we have, I'll move this over a little bit, b is equal to the square root of 43 squared plus 19 squared assume it's the squared here, minus 2 times 43 times 19 times cosine 35. Okay, and what I'm going to do is actually plug that all into my calculator in one step. Just square root first with all this stuff here. Basically, the less times you hit equals on the calculator, okay, the better. And when I do that, I end up with a 29.521, all right, for my little b. All right, so that is how you can use the law of cosines to solve for a side length. Pretty simple, just basically take the square root of the right side of the equation. Okay, next up we'll show you how to use the law of cosines to solve for an angle. Now, there's one detail here. Since I now have little b, it would be tempting to say, hey, I could use law of sines because I have this fraction filled in. Here's the one trick here. In most cases you could. For certain triangles it will work. And for other triangles it will work as long as you get lucky and pick the right angle to solve for. Okay, so this is actually a triangle I picked where if I solve for the A, law of sines wouldn't work, but the C it would work for. Okay, you don't want to take chances like that, so let's just say this. Let's say start with sines. Start with cosine. Finish with cosine. Okay, so in other words, if it's a law of cosines problem, use the law of cosines the entire time. Don't switch over to the law of sines because there is a chance that the law of sines won't work. We'll show you an example of that in a second. Once we get through this, I'll show you why it wouldn't work. Okay? So, I need to solve for either A or C. Doesn't matter which one we use. I'm going to go with A. Okay, so meaning I'm going to pick the equation with the big A in it, and I can use that now because now I know little a, little b, and little c. Oh, can we cram this in here? Let's see. So, A squared, we have 43 squared is equal to 19 squared plus the b we found, the 29.521 squared, minus 2 times 19 times 29.521. We'll just say times, I hate doing this, but cosine A here. We'll clean that up in a second. Yuck. Okay, what I need to do is I need to get this A by itself. So I'm going to start by getting the cosine of A by itself. For that, what I'm going to do is I'm going to start by moving the 19 squared and the 29.52 squared to the left side of the equation. If I had more space, I'd show all my steps. But we'll just kind of talk you through that. So in other words, 43 squared minus 19 squared minus 29.521 squared. Okay, when I do that, I end up with a 616.511. Okay, then the other thing I'm going to do is I'm going to take care of this multiplication here. The negative 2 times 19 times 29.521. And when I do that, I end up with a negative 1121.789 times the cosine of A. Okay, so again, just talking you through that, I subtracted the two things that were being added together here and then just did all this multiplication. Okay, I can't just combine all this stuff together because the negative 2 times 19 times 29.521 is hooked onto the cosine A. Okay, next up what I'll do is I'll divide both sides of the equation by the negative 1121.789. So that'll give me a 616.511 divided by negative 1121.789 is equal to cosine of A. And I'm not actually going to calculate this out on my calculator. I'm just going to leave it like that. Okay, because when I do this division, if I round at all, it's going to really throw my answer off. Okay, then the last step, I've got cosine A. I want to get A by itself, so what we'll do is we'll just take the inverse of both sides, and that's going to leave me with A is equal to the cosine inverse of this fraction here, 616.511. There we go. Over negative 1121.789. Okay, that's going to be what I actually plug into my calculator. Again, it's going to give us not a perfect answer, but as accurate as possible by kind of leaving that as a fraction and not actually calculating it out. Okay, when I plug that in, I end up with a 123 point, we could say 338 degrees for my angle big A. Okay, and then as I run out of room here, I've just got to find big C. Let's get this out of there. And that's just a matter of finding that last angle. Where do I want to do this? I'll go right here. So big C will just be equal to 180 minus the 35 minus the 123.338 we just found. So in other words, big C is a 21.662. All right, so there's my last answer. Okay, so there is using the law of cosines to solve a triangle. Finding a side is pretty simple, just taking a square root. Finding an angle is a little trickier, okay, but I think if you do it these steps one at a time, you're going to be okay with it. Okay, you got to use the inverse, but that's not too bad. And I guess the last thing I want to talk about here quick is this whole starts with cosines, finish with cosines. I just want to prove to you real quick that that's the way you should do it. Where do I have room for that here? Okay, so let's go back to my step where I found B. And again, it might be tempting to say that sine of big B 35 over little b, the 29.521, is equal to sine of A over 43. Okay, because it looks like that would work. It's not gonna though. What are we gonna have here? If I multiply both sides of this equation by 43 and take the sine inverse, that's gonna leave me with A is equal to sine inverse of, let's see here, 43 sine 35 over 29.521. When I plug that in, I end up with a 56.664. Okay, so something different than I got here. Why will that not work? Why couldn't I just have two triangles? Well, let's see what would happen if I found the angle C then. C would be equal to 180 minus the 56.664 minus the original 35. In other words, 88.336. I'm just going to round those to single decimal places so they fit here. Let's see what happens if I did that. C would be 88. The A would be, we'll round that to 57. What I end up with then is an impossible triangle. Notice the largest angle is opposite the smallest side. I can't have that. Okay, biggest angles have to be across from biggest sides, smallest angles across from smallest sides. Okay, so that's why, again, if you start with cosines, finish with cosines, because in certain situations, like you see here, okay, finishing with sines just won't work. All right, problem 2, let's do one more example here. And I've actually shown you everything you need to know for this, but so if you want to pause the video, try to work through this yourself, feel free to do that. Otherwise, we'll work through it together here. So we've got the side case in this case where I know all 3 sides, and if I know all my sides, I can use law of cosines to solve for the angles. Okay, I'm going to space this better, so let's put my triangle up here, let's say. I'm going to make this one look a little nicer than the last one. So little a is 9, little b is 7, and little c is 5. Again, really with this one, I can pick any of these 3 equations to start off with. Let's start by solving for big A. So let's say I have, we'll write it all out, a squared is equal to b squared plus c squared minus 2bc cosine A. Let's fill in what we know to that. We've got the a, which is 9 squared, is equal to b, which is 7 squared, plus c, which is 5 squared, minus 2 times 7 times 5 cosine A. All right, I'm going to try to show my work a little better this time. Start off by moving the 7 squared and 5 squared to the left. So I'm going to subtract 7 squared and 5 squared from both sides of the equation. Again, I cannot combine those with this negative 2, 7 times 5 because it's attached to a cosine A here. So when I do the 9 squared minus 7 squared minus 5 squared, that gives me a 7. So we could say 7 is equal to, and then I am going to multiply this out, negative 2 times 7 times 5, which would be a negative 70. Okay, to get the a by itself, we'll divide both sides by that negative 70. So we have then is 7 over negative 70 is equal to cosine A. And then last step, take the cosine inverse of both sides. So that'll leave me with cosine inverse of 7 over negative 70 on the left is equal to just the a on the right. And when I plug that in, I get a is equal to 95.739 degrees. Okay, so we've got one of our angles filled in. Now again, we started this problem with the law of sines. Let's finish it with the law of sines. I can pick either the b or the c to solve for next. Let's just go with the b. Okay, we'll do a and b. Will we have room? We'll make it fit. We'll just plug things right in here. So b squared, which would be 7 squared, is equal to a squared plus c squared. So 9 squared plus 5 squared. Okay, minus 2 times a times c, so times 9 times 5 times cosine of big B. Okay, again, what I'm going to do is I'm going to subtract the 9 squared and the 5 squared from both sides of the equation. So 7 squared minus 9 squared minus 5 squared, that's going to give me a negative 57. Is equal to, I'm going to multiply these parts together. Negative 2 times 5 times 9 will be a negative 90. Again, one of the big things to watch for in this problem, this is a good example, is making sure you get your positive and negative signs right. Okay, notice over here we had a positive numerator, negative denominator. Here we'll have both negatives. Okay, if the calculator is ever giving you domain errors, chances are you screwed up a negative sign. Okay, we'll divide both sides by negative 90 next. We have a negative 57 over negative 90 is equal to cosine B. And then B is just going to be the cosine inverse of that fraction. All right, so B is a 50.704 degrees, we could say. Okay, then last thing, we need to find angle C. Now I suppose if you're having a ball with law of cosines, you could use the law of cosines again, but I'm just going to subtract from 180. We can say C is equal to 180 minus 95.739 minus 50.70. What is that number? 4. Look back at my calculator, make that look more like a 4. Shoot, I didn't plug this in ahead of time. When I do that, I end up with a 33.557 degrees. Okay, triangle is solved. There's all my angles. All right, problem 3, let's take a look at one more problem real quick. And I say real quick just because this will be a no triangle case, just like we saw with law of sines. And the thing we're watching for here is, notice I've got my side, side, side again. So when I go to draw this triangle up, we'll show you what happens. We've got A, B, C with side lengths of 16, 5, and 8. Okay, now a theorem we gave you back in geometry class, the triangle inequality theorem, said that no one side of a triangle can be bigger than the other two sides combined. So for example, here we have that 16 is greater than 5 plus 8, 13. So if I want to draw this triangle to scale more, what I'd actually end up with is something that looked more like this. I'd have two arms that are too short. They couldn't reach to touch each other because what's in between them's too long. Okay, so that's how I know I have no possible triangle here. Okay, because I have one side that's greater than the other two combined. Okay, now a nice thing about this one is if you went to set up the law of cosines and started solving, calculator would give you a domain error, it wouldn't let you solve it. Okay, so there's a nice little built-in check to our formulas. It's not going to let us get answers for a triangle that doesn't exist. All right, there you go. That's the law of cosines. Okay, equations are a little messy when you first start working with them, but it's a lot of the same stuff over and over again. You'll be okay with them. Okay, so give the homework a shot, rock through that assignment. Let us know if you need help, and we'll see you guys later.